Hello everybody and welcome to exercise 6. And in this problem we're being asked to find the area of a region bounded between two curves. Been a while since we've done this. Alright, so let's start with a sketch of the region that we're given here. So if we look at the two bounding curves that we have, so 2x minus y equals 0, notice that we can rewrite that as just y equals 2x. That's just the equation of a line. And then similarly, x squared minus y equals 3. If we rewrite that and solve it for y, we're going to get x squared minus 3, which is a parabola. Okay, so just in terms of a rough sketch here, okay, y equals 2x is a line that has a slope of 2 and goes through the origin. Okay, so it kind of looks like that. And then y equals x squared minus 3, that's a parabola. Okay, you could double check me with a graphing calculator. And so you can kind of see the region that we're talking about. That would be the region that's bounded in between those that I'm shading here. That's the area that we'd like to find. Okay, and well, let's maybe go ahead and label our curve so we can see that as well. So we've got y equals x squared minus 3 there, and y equals 2x on the top. Okay, and you might remember that our technique for finding area was we just need to integrate the difference of our two functions. And the decision that we need to make is, do we want to think of this as an integral in terms of top function minus bottom function or right function minus left function? Notice that since we're solved for y, it's natural to think vertically in this problem. Okay, think of a rectangle that sort of goes from the bottom curve up to the top curve. We can see from the formulas what the y-coordinate at the top and the bottom of that rectangle would be. Okay, and so our area then is going to be an integral of the top function minus the bottom function. And so let's see, the curve that's on the top is 2x, and the one that's on the bottom is the parabola, the x squared minus 3. Only problem is there's one thing missing from this integral. Do you see what it is? We don't know what our limits of integration are. We need to figure those out. Okay, so where do we start and where do we stop? Well, we're going to start and stop at our points of intersection that I'm highlighting here. So we need to do a little algebra problem and figure out what those points of intersection are. Let's see if we can sneak that calculation in up here. All right, so easiest way to do that is just to take the two curves and set them equal to each other. So y is equal to 2x. The other one, y is equal to x squared minus 3. Okay, that gives us an equation that we can solve here. So if we subtract the 2x to both sides, x squared minus 2x minus 3 is equal to 0, and that looks like it factors. And you can see then that our points of intersection appear to be -1 and 3. Those should be the limits of integration for us. All right, so let's fill that in. We're integrating from -1 to 3. Okay, and all that's left now is to actually do the integral and see what we get here. Okay, well, let's maybe start by just factoring that minus sign through, or distributing that through. So we're going to get minus x squared plus 3. Okay, then we need antiderivatives, so let's see. Antiderivative of 2x is x squared minus x cubed over 3. Okay, and the rest is really just arithmetic here. Okay, so 3 squared minus 3 cubed over 3 plus 3 times 3, all of that minus our lower limit. Okay, and the rest of the details here, actually doing the arithmetic, I'm going to leave it to you. You can double check and confirm that if you do all the algebra there, what you should end up with is 32 over 3. That's our actual area. Okay, and we're done.